What's up, guys? It's Will Youngle. Here to kind of go over our Algebra 1 summer school packet. A few things I wanted to show to you guys. We're going to walk and talk through this real quick. You should have received this front packet. It has 6 homework assignments in it, and within those 6 homework assignments, we're going to do a brief overview of what you need to do. So if you go to your first assignment called Graphing Linear Equations, you are going to graph linear equations. So the only information you need is the formula y equals mx plus b, which is your slope-intercept form. M is your slope, which is rise over run. B is your y-intercept, which is the first point you should plot. For example, I did number 2 for you. -3 is your b, or your y-intercept. So once you plot that, which is right here, you go to your slope, which is rise over run. We should be rising 1 and running 2, but it's negative. So instead of rising 1, we're going to go down 1 and then to the right 2. So from our point, we go down 1 and we go over 2. Done. Make your line. You're finished. If you don't see a number in front of the letter X, you can always assume that that number is 1. You can make it a fraction. For example, -2. By putting it over 1. That should solve all your problems for that assignment number 1. Okay, next one, assignment number 2. We're trying to learn how to find slope given a line. Well, remember, slope is rise over run. So it's taking a point such as this one right here. You start at your left point and go to your right point. So furthest left is here. I need to get to here. Well, how much do I rise? I rise a negative amount. I'm going down. That is 1, 2, 3, 4, 5, 6, 7, 8. I went down 8, and I'm going 1 to the right. So my slope should be rise over run, -8 over 1, which is -8. When you run into this situation, this is finding the slope of a line through a pair of points. All you need to do is label your point x1, y1, x2, y2. You plug them into our slope formula, which says y2 minus y1 over x2 minus x1. So in this case, you would have, I just kind of gave you a shortcut, always make a line and 2 minus signs. And for this problem, I would put y2 right here. So it'd be 14 minus y1, which is 17. And then x2, -15, minus x1, which is 3. You want to be careful. Sometimes in some problems, you might end up with a double negative. So remember, that becomes positive. And you get your final answer, which should be a single number or fraction. Okay. Assignment number 3 was adding and subtracting polynomials. So really all we're learning how to do is combining like terms is the big thing. I did this bottom example for you because when you see a minus sign by itself, you can always assume it's really a -1 right here. So I drew one in here for you. Nothing happens to the first set of parentheses because there's really an invisible positive one. Nothing changes. So we can rewrite the first parenthesis. Then this -1 right here is actually distributing into all 3 terms. So -1 times 4 is -4. -1 times 6x to the 4th is -6x to the 4th. -1 times -2x squared, negative times a negative is positive, now be 2x squared. After that, we combine like terms, such as -2x to the 4th would go with -6x to the 4th to give you -8x to the 4th. 5x squared and 2x squared makes 7x squared. And lastly, 7 and -4 is 3. That is your final answer. Okay, next homework was graphing inequalities. So there's a few things you need to remember about graphing inequalities. It's very similar to graphing lines. For example, y is greater than 2/3 x plus 2. You would graph a line like you normally would. You'd start at +2 on the y-axis, which I did. And look, your slope is 2/3. You would rise up 2 and run 3. So rise up 2, run 3. Now, normally you would make a solid line, but here's where we're talking about inequalities. So a couple things to remember. If you see a less than or greater than sign, it's a dotted line. In this case, it is a dotted line. If it was underlined, like this example is, you should expect to see a solid line. Next, after we draw our dotted line, we need to know which way to shade. Well, if it's greater than or equal to, we're always going to shade up. And what I mean by that is if I put my hand on the line, where's up? Up is up that way. If it was less than or equal to, I would be shading down, which would be the opposite side. Okay, moving on to assignment number 5. Assignment number 5 is basically your FOIL method, multiplying polynomials. For example, this one. Some people like the FOIL method. Some people like the box method, so I showed you both in this example. 4k times 4k, you would take the first term, multiply it by everything in the other parenthesis. So in this case, 4k times 4k is 16k squared. Then 4k times 2 is 8k. Then you take the second term and distribute it into both. Negative 3 times 4k is negative 12k. Negative 3 times 2 is negative 6. Combining the like terms, which are only these two, that 8k minus 12k is negative 4k. And that would be your final answer. The box method is a little easier to follow. 4k minus 3, I can write here. 4k minus 3. 4k plus 2, 4k positive 2. Now you cite multiplication tables. You can multiply 4k times 4k to give you 16k squared. 4k times negative 3 gives you negative 12k. 2 times 4k is 8k. 2 times negative 3 is negative 6. Notice all 4 of these are the same 4 things that we had here. Either way, you're going to get the same correct answer after you combine like terms. Number 8, a little bit trickier. Remember, this is only 2 things times 3 things, or a binomial times a trinomial. So you take the first term, multiply it by all 3. Then you take the second term, multiply it by all 3, and combine like terms. This might get a little confusing with the arrows, so again, you can do the box method. b plus 1, put a b and a 1. 3b squared, 5b minus 1. 3b squared, 5b minus 1. And again, this is the multiplication tables and combine like terms. Your last assignment was assignment number 6, And all we're doing here is solving each system by graphing. And notice you get 2 lines in every problem. So here's how this works. 2 lines, all they can do is 3 things. They can cross, which your answer would be where they cross. 2 lines can be parallel, meaning their slope is exactly the same. They will never cross, meaning you will not have a solution. Or it could be 1 line on top of another line. Camera's kind of on. There you go. 1 line on top of the other. That means you have an infinite number of solutions because they have an infinite number of points in common. So I did this example for you. Graphing lines like usual. Plus 1 on the y-axis. Up 2 to the right 3. Up 2 to the right 3. I graphed my first line. Graphing the second line. Negative 4 on the y-axis. Remember, the slope here is negative 1. As a fraction, it would be negative 1 over 1. So I should be able to go from my negative 4, negative 1, and over 1. So once we graph our 2 lines, we want to know where do they cross. So when you take a look at this, they cross at this exact point. Well, what is that point? That point is negative 3, negative 1. That's your answer. So guys, I do wish you the best of luck over the summer or catching up on your work. Remember, you can contact any of us at any time, and I hope you're doing well.